your homework is to complete the back of the notes sheet that was passed out last class. If you don't have a copy of this piece of paper, you can log on to Google Classroom and you can print it out. So last class we talked about solving systems of equations that were linear, and now we want to talk about solving systems of equations that contain quadratic functions in them. And we can solve them the exact same way. We can solve them by graphing, by substitution, or by elimination. So this first example I'm going to do by graphing. So my second equation here is a linear function, so I'm just going to go ahead and graph that. So I'm going to graph 4, and then go up 2 over 1, down 2 over 1, and graph. And I'm going to, when I graph and I'm doing systems of equations, I'm going to graph all the points possible. And then I'm going to connect my dots. Okay, so now I want to go ahead and I want to graph this quadratic equation. So since this quadratic equation is in standard form, it opens up. My axis of symmetry is x equals negative b over 2 times a, so x is negative 2. My vertex is negative 2 comma, and I gotta plug negative 2 in. So I have 4 minus 8 plus 4, so 4 minus 8 is negative 4 plus 4 is 0. My y-intercept is 0, 4. And my x-intercepts, I have to factor that, so it'll be x plus 2 and x plus 2. So x is negative 2, so my x-intercept is negative 2, 0. So negative 2, 0 goes there. And then my axis of symmetry, my vertex is negative 2, 0. My y-intercept is 0, 4. And I do my reflection point. Now I'll draw my parabola. And notice my solution to the systems of equations is where my functions intersect. So they intersect there and they intersect there. So when I write my answers, I'm going to have 2 answers. So my first answer is negative 2, 0, and my second answer is 0, 4. So now I'm going to go ahead and I'm going to solve by substitution. So when I solve by substitution, I want to get one of my variables alone, so then I can plug it into the other equation. So notice y is alone in both of these problems, so I can just automatically go ahead and set these equations equal to each other, because I'm just going to replace this y with that y. So when I see that y, I'm going to plug in 2x minus 9 equals negative x squared plus 8x minus 14. And now I'm going to solve. So I'm going to add x squared to the other side, subtract 8x, and add 14. I get positive 5. So now to solve, I'm going to factor for x. So I have negative 5 and negative 1. So x is 5 and x is 1. So now I have 2 solutions for x. So I'm going to take this first x value and I'm going to plug it into one equation. I could plug it into the one I just circled, or I could plug it into this one. But obviously the bottom equation is quicker to plug it in, because if I plug it in, it'll be, to find y, it'll be 2 times 5 minus 9, which is 10 minus 9, which is 1. So my first ordered pair is 5, 1. In my second ordered pair, I'm going to plug in 1. Y equals 2 times 1 minus 9. So 2 minus 9 is negative 7. So I have 1, negative 7. So what that tells me is when I graph this parabola with this line, they're going to meet at 5, 1, and they're going to meet at 1, negative 7. And I'm going to come over here and I'm going to graph it to show you. So because I circled my linear function in red, I'm going to go ahead and graph my linear function in red. So up 2 over 1, up 2 over 1, that's 3 over 1. And I'm going to go all the way across my grid. And then I'm going to connect my dots. So now I have to graph this right here. So in order to graph that, it opens down. My axis of symmetry is negative b over 2 times negative 1, which is 4, equals x. My vertex is 4. And I gotta plug in 4. 4 squared is 16, so negative 16 plus 32 is 16, minus 14 is 2. My y-intercept is 0, negative 14. And my zeros are going to be an irrational solution, so I'm not even going to find them because it's not going to help me graph them. So I have 4. So 4, 2. And then I have my y-intercept is 0, negative 14. So if I go 1, 2, 3, 4, 1, 2, 3, 4, should be right around there. So obviously this isn't helping me get any of my answers, so I'm just going to go back and use my vertical shift. So since a is 1, it's just a normal parabola. So over 1, down 1, over 1, down 1. That intersects once. Over 2, down 4. Over 2, down 4. And then it'll be over 3, down 9. And notice, now I found my intersection points. So let's go ahead and do the next one. So here, because y's are already by itself, I'm going to go ahead and set them equal to each other. So negative 1/2 x squared plus 2x minus 1 equals 1/2 x squared plus 4x minus 4. So I'm going to add 1/2 x squared to the other side and just get x squared. And then I'm going to subtract 2x and get 2x. And I'm going to add 1 and get negative 3. So now I'm going to go ahead and factor to solve for x. So I get positive 3 and negative 1. So x is negative 3 and x is 1. So now I have to take these solutions to find my y values. So to find my y values, I just take my answer and I plug it into any equation that I want. So since this one has no negatives, I'm going to plug it into that one. So y equals 1/2 times negative 3 squared plus 4 times negative 3 minus 4. So negative 3 squared is 9, so I have 9 over 2 minus 12 minus 4. So 9 over 2, negative 12 and negative 4 make negative 16. So now I've got to find a common denominator, which is 2. So now I have 9 over 2 minus 32 over 2. So 9 minus 32 is what? Negative 23 over 2. So now I'm going to go ahead and plug it in 1. So 1/2 x squared plus, well, on x squared I want to plug in 1. So 1 squared is just going to be 1, so it's 1/2. Plus 4 times 1 is 4, minus 4. So 4 minus 4 makes 0, so y is 1/2. So my ordered pairs, negative 3, negative 23 halves, and 1 1/2. So now we're going to come along and we're going to talk about solving by elimination. And one thing is what I could say is we can now go ahead and graph this problem. However, I'm not going to be able to easily determine that on the graph because my y-coordinate is a fraction. So you can graph it if you want for practice, but you don't have to. So if I go through and solve this by elimination, your goal is to get your variables to be inverses of each other. So because I have two x's, I would have to make this an inverse and this an inverse at the same time in order to be able to solve this equation. So eliminating your x's when you have quadratic functions is actually quite challenging. Instead, it's easier to make your y's inverses of each other. So my y's right now are both positive 1. So to make them the inverse, 1 needs to be negative 1. So I'm going to multiply this bottom equation by negative 1. So I'm going to have negative y equals negative 3x squared plus 2x plus 5. It does not matter which equation you multiply by negative 1. I just picked this one because it had negatives. So now I'm going to take this equation, and I'm going to add them up. So y's eliminate. I'm left with 0. 4x squared and negative 3x squared make x squared. 8 and 2 make 10. X. And then 4 and 5 make 9. So now I'm going to go ahead and I'm going to solve. And how do I solve? I'm going to factor. X plus 9 and x plus 1. So x is negative 9 and x is negative 1. So now I have to go and plug it into any one of the equations to find my y value. So I'm going to do 4 times negative 9 squared plus 8 times negative 9 plus 4. So I have 81 times 4. Which is 324 minus 72 plus 4, which is 256. That's y. So my one ordered pair is negative 9, 256. So this would clearly suck if I had to graph it because that would go off my grid. And now if I plug in negative 1, I have 4 times negative 1 squared plus 8 times negative 1 plus 4. So negative 1 squared is 1, and then 4. 8 and negative 1 make negative 8, and then plus 4. So 4 and negative 8 make negative 4. Negative 4 and 4 make 0. So my other ordered pair is negative 1, 0, and I'm done. If I come over here and I look at the last one, I'm going to have you try to solve this one on your own. But in order to successfully use the elimination method, your y values and your x values have to be stacked on top of each other. So right now, and they have to be on the same side of the equal sign. So notice that x and y are on the left, on the top, but on the bottom, my y's are on the left and my x's are on the right. So in order to be able to successfully use the elimination method, your x's have to be and your y's have to be on the same side of the equal sign. So you really want to change this bottom equation first before you start solving. So try this problem and then we will go over the next class.